way. Old technology, old plants, old boys. Okay, and everybody in the branch knows that that is not true. And therefore I like my mobile, because if you have a mobile, there is some tiny piece in where this mobile is not able to work. It's a vibration alarm. I don't ask you how this works. I only can explain that there is a tiny, tiny small piece in, with a sintered in a furnace, and is responsible for the vibration. That means, with us, from our industry, this vibration alarm never works. And therefore, I'm very glad that I get this mobile. Okay, but now coming to my point, energy efficiency for industrial thermal process equipment, the way Europe is going. I first want to give a short information about the FOGI, the research agency, and then I will give you a short information about the introduction about energy efficiency in global. Then I come to my topic, the EU directive, energy-related products, called ERP. And then I try to give you some advices how to save energy, but I've heard during lots of presentation that most of you have picked it up. I want to make it a little bit theoretical, and at the end I will give you an overview, only one slice, about the ISO standards about energy efficiency. Okay. I'm here because I'm representing the FOGI. The FOGI is a research association for industrial furnace manufacture, but I'm also working for the VDMA, the German Engineering Association, and therefore in the group of thermal process technology, that whenever you come to Germany and ask for, have some question about furnaces, not how they work, but in principle, then you are with me. And I'm also a senior consultant of CECOF, and René Brandas is the president of CECOF, and of course, Dr. Seitz is the president of the Association of Thermal Process Equipment inside the VDMA. And I'm also representing ISO TC 244 and CEN-TC 186 here. But there are only one slice. All three, FOGI, VDMA, and CECOF, are non-profit organizations. That's important. Now, some slides about the FOGI, short information. Okay, common research. Common research means an intensive and practice-related research is required, especially in the field of thermal process technology, in order to meet the high technical and economical standards. Due to the limited budget within most companies, there are often these are often not in the position to independent finance a basic research work on heat transfer, manufacturing cycle, and combustion processes. Therefore, mainly small and medium-sized enterprise benefit from common research work by independent research institutes. What does it mean in practice? You have a group, members of our association, and if some or all have a special question, technical question, material question, then they can ask the research association, and we work together with independent research institute, mostly from the university, to find ways to get a solution. And it's always a question of financing. But we got it in the past. Okay, our members are working in the field of heating, melting, casting of materials, heat and surface treatment of metals, and also ceramic and glass, and of course, combustion technology. Main research activities, only to give you a feeling: metal dusting, isolation, there's a typing error, burner, emission reduction, furnace installation, vans, radiating tubes, charging racks, and rotating furnaces. Metal dusting is one of point which was very interesting, for example, for the heat tubes of Driva. There you have lots of metal dusting, and it's not solved the problem. Okay. So I start with my topic, energy efficiency. There is one big question always. Is there a correlation between combustion of natural gas, oil, diesel, petrol, and the production of TO2? Yes, there is. Otherwise, I would not ask the question. And what is the question? For natural gas, you can mention for 1 cubic meter natural gas, you produce round about 1 cubic meter CO2, 1 to 1. That means if you talk about reduction of CO2, we always have in mind that 1 cubic meter natural gas produce 1 cubic meter CO2. And I put the same data for oil and diesel here. I forgot the data of petrol because I'm driving a petrol car, and it's worse than the others. Okay. Why should we save energy? First, increasing energy costs. That's clear for everybody. Preserve resources. That's also important. And climate regulation. Yes, of course. Legislation. Delhi, Brussels, Berlin. And if you came from other countries where this government is sitting, then you have to add other towns here. And, of course, reducing dependence on imports. This is very important. And growth in employment, because it's also as an import. And there are lots of other arguments why you should save energy. And you can choose what you want. Yeah? But I will have a point on the force of Brussels, yeah? The EU. Okay. Now I try to give you an example how the energy used went into the last years. I started in 2000 and stopped in 2011. I think I start with the red one. This is European Union, it's EU 27. And you see, we do not save so much CO2. I was glad when I saw the figures from 2009. I said, now we are starting, but 2009 was a very, very bad year for our branch, for the branch overall, and therefore the figures in 2009 goes a little bit down. It had nothing to do with real saving. And in India, it's more or less the same, and this is the overall curve. That means in reality we do not save energy worldwide. And we know the relation 1-to-1. I have the same diagram for CO2 and same situation. In Europe we save a little bit. In US we save a little bit, but the light blue one is China, and this destroys everything. That means we come to a real situation that we do not save nothing. So, if you think on the green grass, green emission, then we have a real problem in the world. We must do something, everybody knows, but it depends on the economy. Only to give you a motivation to think about CO2 and to think about energy efficiency. Okay, now we come to the hardcore subject, what's going on in Europe. If you ever talk about Europe, then you have to discuss things about the European Commission. The European Commission said we have to reduce CO2, and there are two strong arguments. One is two directives. One is so-called Eco-Design Directive from 2009, and the other is the Energy Labeling Directive. The Eco-Design Directive is a directive on establish the framework for setting a product-specific eco-design requirements for energy-using products. I've put the CE mark on this directive. In Europe, if you ever try to sell and you want to sell a machine in Europe, then you have to put the CE mark on this. CE mark means that you fulfill all the requirements of this machinery directive, mostly. But in the future, if you put the CE mark on the machine, you also have to fulfill the requirements of the Eco-Design Directive. That means this is a very, very hard thought. In the future, CE mark means Eco-Design Directive and Machinery Directive. That's different. And on energy labeling, there's a directive on establish a future for products. But I think it's not necessary for furnaces. For domestic products, when you ever sell, for example, a washing machine or a van or a TV in Europe, then you see this energy labeling, and this energy labeling give you a feeling how much energy efficiency is an equipment. At this time, you normally buy a washing machine only if the energy labeling is A. B is worse, and the others are never used. That means it's an advice if you come home to your lady and say, if you ever buy a washing machine, look to the energy efficiency labeling. But in Europe, okay, both directives are compulsory. Okay, I now start about the Energy Efficiency Directive. What is the aim of and the background of the Energy Efficiency Directive? The aim is promotion of suitable developments through the free movement of energy-using products, environmental potential, and increase security and of energy supply. Background: consider all environment aspects of the product through their life cycle. Life cycle means develop the product, the furnace, using the product and refurbish of the furnace, the fully life cycle. And the energy design approach is search for design options that could improve the product environmental performance and balance with technical and economical constraints. Scope: all energy-using products except the transport sector. Energy-using products are in the domestic and in the technical area, of course, and, for example, windows are also energy-using products in the sense of this directive. Yeah? Target group: manufacturers, of course, suppliers, dealers, and importers of energy-using product. That means the fully chain. Yeah? And this direct is, from the ambition efforts of the EU Commission. They want to increase the energy efficiency up to last week by 20%. But last week we have a meeting of all the prime ministers of the EU, and they changed the 20 to 40%. Increase energy by 40% overall, of all countries, of all products in the EU. And reduction of greenhouse gases, the old one was 20%, and now last week they decided to come to 29%. And renewable energy, they also decide to go up. Yeah? This means in a period from 1995 to 2035, you have to reduce the energy efficiency by 40%. And if you remind the diagram I start with the CO2, that will be a hard work. I have no idea what will happen if we not fulfill this requirement, but this is the truth and this is law in Europe. So, reducing the environmental impact of products, in principle, everything influences the environmental. Present focus is on energy efficiency, of course, but also water could be a part of this energy efficiency. And the next paragraph, New Approach Directive, is only for the people who have a background as a lawyer, yeah, because it's very important, but not for you, yeah? Okay. And only products which fulfill the requirement of the ERP could be placed on the market. Mandatory. You must fulfill these requirements, otherwise you are out. And we are talking about life cycle approach, and of course it's a dynamic minimum requirement. That means in the future, if the requirement, it could be possible that the requirement go up. Okay, so for which products? First, you start with requirements in the domestic area. It's the easiest way. Domestic boiler, water heaters, TVs, for example, washing machines, and so on. And then they start with electric motors with less than 150 kilowatts, with water pumps, and with vents for ventilation. And they said, okay, domestic is one area, then we go to products, and then we try to find solutions how we can reduce the energy efficiency for industrial purpose. And they started with professional refrigerant transformators, of course. And now industrial furnace and kilns, these are the most important thing for us, and tooling machines, and they also start with boiler. I only add boiler because I start with domestic boiler and the industrial boiler in. That means up to 2016, 2017, we will have requirements for the energy efficiency for industrial kilns, ovens and furnaces. Now we'll give you some examples that you have a feeling what do the Commission means. So the Commission want to reduce the energy efficiency, and if the Commission wants to do something, they first ask a consultant. And the consultant has calculated that for all furnaces up to 2035, you can save 1,650 terawatts per year. I have no idea in which way they can calculate it, because in my eyes it's impossible, but they come to the result. Good consultant, maybe he has come from our area. I know that he does not come from our area. Okay, with small furnaces you can save less than 1%. Small furnaces are laboratory furnaces, for example. The definition on this page. With medium furnace, you can save 12.5%, and with large and very large furnaces, you can save 87% of this 1,650 terawatt. Now, the problem with very large furnace is that these furnaces are normally customer sites. You can't buy them from a catalog. They are customer sites and cost a lot of money, and therefore it's very hard to say how they come to the 87%. But this is the way like it's working in Europe. Okay, that means you can save. And during this definition, now I know the difference between a furnace and an oven. I was very surprised. A furnace is an equipment, a temperature equipment with a temperature less than 450 degrees. A furnace is up to 450 degrees. But this is the definition of the Commission, but we have to live with. Okay, now how we can save energy. There I come to the 3 rules, I would say, 3 rules. For industrial kilns, furnaces and ovens, CECOF, which is the European Association of Thermostats Manufacturers, has defined these 3 rules. The first rule, saving energy for thermostat equipment in the way of requirements, are the outer surface temperature. I'll give you an explanation after. The second rule is the air-fuel ratio. It's also clear. And waste heat recovery requirements are the third rule. And we have heard today lots of things about waste heat recovery requirements, and examples how you can use it. That means it is clear. And I'm very surprised, and everybody was very surprised, that our Japanese friends, they have developed the Japanese Energy Act, came to the same solution than we as Europe. And I've hoped, and I will hope, if you in your country think about these, you can also do the same results. I hope this will be the way. So we talk about these 3 rules in an example. So heat recovery. Don't try to learn all the figures. I only want to explain one figure, and this is example 1b, large furnace with an inside temperature above 1,000 degrees. Typical furnace in the steel industry, typical furnace in the typical kiln in the porcelain industry or the cement industry. And that the Commission said up to 2025, the flue gas must less than 300 degrees. flue gas input at the chimney less than 300 degrees. And this is a hard thing. And they say they measured it with 3% O2. That's only in case that you put a little bit air in to reduce the flue gas temperature. 300 degrees, that is the target. That means we have a maximum energy saving and energy recovering by 55%. This is more or less the same, 55%. And if you think about that you need a little bit, most of the energy inside the furnace to heat up or melt the material, we only talk about the heat losses of the furnace. This is very hard, but it's 2025, and I personally believe that the manufacturers everywhere can fulfill this requirement. But it must be clear that it costs money. It costs money to install equipment that you can fill these requirements, but these requirements came from the basic of saving energy. Okay, next one, isolation. And we also go to, say, the big furnace, the same go to B6 on the topic, on the basic. That means for the big furnace, the outer heat transfer must be less than 500 watt per square meters. You can fulfill these requirements, this is no problem. But some material is high temperature wool. You must use high temperature wool to fulfill these requirements. Otherwise, your wall get very, very thick. Yeah, okay. And we are glad that they have the heat transfer here in and not the temperature. The first shot of the commission was to have the outer surface temperature, but it makes no sense because if you have the outer surface temperature of 40 degrees and the temperature of the environment is 40 degrees, it makes no sense. It's physical and not fulfillable. That means 500 degrees or 400 or 300, it depends on the type of furnace, it depends on the size of the furnace, and it depends on the inside temperature. Yeah? And then we came to air-flue gas ratio. You know that the best way and the optimal way is to have so much air as you need for the combustion process. That means 1. But realistic, a number of 1.25 is good. If you try to reduce it a little bit to 1.25 or 1.15, it's better. But 1.15 is say the end on the technical way. Otherwise, if you have small fluctuation, then they go into a negative way. That means into an air gas ratio less than 1, and this is for some projects a real problem. Okay, that means in the future you have to fulfill these requirements. The Commission is make it mandatory that and then you can have it black on white, and then you must fulfill this, otherwise it's not allowed to build up this project and bring it into the market in Europe. This is the way Europe thinks about energy efficiency. Okay. Some advice, how you can, and some remarks first from me. Due to their manifold application, industrial furnace and kiln spend approximately 40% of all end energy use for industrial purpose in Germany. Round about 40% is more or less in the same area in each country. 40% of energy used in the industry is used by our furnace. Okay. And energy saving, by the way, is not a point we, as in our branch worldwide, start thinking since a few years. We think about energy efficiency since 10, 20, 500,000 or more years, because energy efficiency was one of the points we start when we start with our business. Otherwise, you can't use furnaces, and energy is the most important thing. Okay, life cycle time of an equipment is round about 30 years or longer. It depends on the equipment. And nowadays, with a new furnace design, you can save round about 30% energy. It's a question of what is the relationship, but if you compare a furnace which is 30 years old, then you can save 30% energy. That's realistic, that's not realistic. Okay, activities of the VDMA and of CCOF. We have written energy efficiency guideline for thermal process equipment. And this guideline gave you examples how you can save energy. That means we have designed the knobs you can turn on saving energy. Because we get the feeling that lots of customers have a lack of information, a lack of technical experts, and therefore we designed this and we developed this, my last slide, and we explained this, how you can change these knobs to saving energy. And we say first is wall construction, wall losses. The main point is that you have to divide between continuous and batch type furnaces. That's a different sort of building up the isolation, and RCF is also a point. Heating, we have heard from the presentation from Dreva and other colleagues that preheating of the combustion air is one of the easiest things of saving energy, or using regen or recuperator, but the same. And process optimization is one of the very interesting things. That means design the TPE, the thermal process equipment, in the way that the energy you have inside the product you can use a second or a third time. This is very interesting. Waste heat recuperation we have had. There's no discussion. And you also have an eye on subsystems and auxiliary units like electric motors and protective gases. My personal feeling is, and meaning is, that in the future we as manufacturers of thermal process equipment have to think about solutions which are not our basic job. That means we must think how we can combine the energy coming out of a furnace with other equipments inside the plants or in households. This is not our basic point, but we have to have an eye that we can use the hot water, for example, outside the furnace for other equipment. And we have an example, for example, that you can use the waste heat to heat up a complete area for domestic houses. This is possible. Or that you can heat up, it's a very stupid, but I saw one example, that you can heat up with the hot water an area where fishes are living, yeah? Because the water is a little bit hotter, they grow a bit faster, and then you can eat them quicker. Okay, that means we must think about some exotic solutions in the future, and I think this is the game we have to play. But we play these games in lots of years, in thousands of years, and we were able to do. Thank you.